The skull of a short-faced bear is roughly the size of a garden shovel blade. That is not an exaggeration for effect. That is just what it is. And Alaska's frozen ground has been handing them back to us, one thaw season at a time, along with the bones of creatures so large and so strange that even veteran paleontologists describe the Pleistocene megafauna of the far north as something closer to a fever dream than a chapter of natural history. Today I want to take you into that boneyard. Not just the physical one, the muddy riverbanks and eroding bluffs where ivory and bone keep tumbling out of the permafrost, but into the deeper mystery underneath it all. Because the short-faced bear is only the beginning. Behind it stands an entire vanished world. Mammoths, mastodons, cave lions, giant ground sloths, horses, camels, and the stag moose. An animal so improbable it barely sounds real. They were all here. They all disappeared. And we still are not entirely sure why. So here is what I want to work through with you today. Who was this bear, really? What does Alaska's permafrost actually preserve? And why does it keep producing things that seem to belong in mythology? And then the big question, the one paleontologists have been arguing about for decades. What killed all of it? Because the answers are stranger and more contested than most people realize. Let us start with the bear itself, because until you truly understand what this animal was, the rest of the story does not land the way it should. Arctodus simus. That is the formal name. The short-faced bear. The short-face part refers to the proportionally compact, almost dome-like shape of the skull compared to a modern grizzly's longer, more tapered snout. But do not let the name fool you into thinking smaller. The skull I mentioned, the one the size of a shovel blade, belonged to an animal that, on all fours, stood roughly at the shoulder height of a large horse. When it reared up on its hind legs, which bears do regularly, and which this one almost certainly did, estimates put it somewhere around 10 to 11 feet tall. For context, that is tall enough to look down on most doorways from above. The body plan was unusual even by bear standards. The legs were longer relative to body size than in any modern bear species, giving Arctodus a rangy, almost greyhound-like posture compared to the stocky build we associate with a grizzly or a brown bear today. Some researchers have suggested those long limbs made it capable of covering ground at a surprising pace. Others have argued the opposite, that the limb proportions were more about reach than speed. The debate is genuine and unresolved, which is actually one of the things I find most fascinating about this animal. We have the bones. We still cannot fully agree on what the creature was doing with them. There is a similar argument about diet. For a long time, the short-faced bear was cast as the ultimate apex predator of Pleistocene North America, a hypercarnivore that ran down prey the way a lion does. More recent analysis of bone chemistry has complicated that picture significantly. Some specimens show isotopic signatures consistent with a heavily meat-based diet. Others suggest something more omnivorous, or even a degree of scavenging. The current best guess, and it is genuinely a best guess, is that Arctodus was probably an opportunist, big enough to steal a kill from nearly any other predator on the continent, capable of hunting when it needed to, smart enough, presumably, to take the easy meal when it presented itself. In other words, it may have been less a pursuing killer and more a terrifying landlord, the animal that showed up and simply took what it wanted. Now, where Alaska fits into this. Alaska during the last ice age was not the frozen wasteland you might picture. Most of it was not actually covered by glacial ice. Instead, much of the interior and the north sat within what scientists call Beringia, a vast, cold, dry grassland that stretched across what is now the Bering Sea floor all the way into Siberia. This was the Mammoth Steppe, and it was one of the most productive large animal ecosystems in the history of the planet. Herds of woolly mammoths and woolly rhinoceroses. The rhinos were more Siberian, but the point stands. Alongside horses, bison, caribou, and the short-faced bear and other predators who fed on all of them. It was Africa's Serengeti, but colder, bigger, and weirder. When that world ended, the permafrost sealed it. Permafrost is exactly what the name implies. Ground that stays frozen year-round, sometimes to depths of hundreds of feet. In Alaska and across the Yukon, this frozen layer has acted as a natural deep freezer for the bones, teeth, and occasionally the soft tissue of animals that died during the Pleistocene. Riverbanks erode, Bluffs collapse into creek beds, and out come the bones, mammoth tusks, bison skulls, horse teeth still holding their enamel gloss after tens of thousands of years. And yes, the occasional relic of Arctodus, a jawbone, a femur, a skull that makes you stop and just look at it for a while. Gold miners working the creek beds of interior Alaska and the Yukon have been turning up Pleistocene bones for well over a century. Hydraulic mining, using high-pressure water to strip away frozen sediment, is particularly effective at exposing them. Some of the most remarkable specimens in museum collections came not from a scientific excavation, but from a miner who stopped his equipment and called somebody who knew what they were looking at. There is something fitting about that. The people working closest to the ground, in the most literal sense, have often been the ones who kept pulling this lost world back into the light. But here is the question that starts to press on you once you understand the scale of what was living here. How did it all vanish so completely? Because it did vanish. Almost all of it. The short-faced bear disappears from the fossil record somewhere around 10 to 12,000 years ago, give or take, right at the end of the Pleistocene, the geological epoch that closed out the last major ice age. And Arctodus was not alone. The woolly mammoth went with it, the mastodon, the American horse and the American camel, both of which had evolved on this continent over millions of years and had never existed anywhere else. The giant ground sloth, which in some species approached the size of a small elephant. The saber-toothed cat, the American lion, which was larger than any lion alive today. Within a geologically brief window, a few thousand years at most, possibly far less in some regions, North America lost the majority of its large mammal species. It was one of the most dramatic extinction events of the last 50,000 years, and it happened to the animals that were, by any measure, the most impressive ones on the planet. Now, two explanations have dominated the debate for decades, and neither one has fully won. The first is climate. The end of the Pleistocene brought rapid, dramatic shifts in temperature and vegetation. The mammoth steppe, that cold, dry, highly productive grassland, shrank and fragmented as the climate warmed and moistened. Forests replaced grasslands in many regions. The plant communities these animals depended on changed faster than some species could adapt. There is strong evidence that habitat loss was a real and serious pressure on megafauna populations across the northern latitudes. Nobody seriously disputes that climate played a role. The second explanation is us. Humans crossed from Siberia into Alaska and spread through the Americas during this same period. The timing is, at minimum, uncomfortable. In region after region, the arrival of human populations is followed, sometimes closely, by the disappearance of large mammals. The overkill hypothesis, as it is often called, argues that human hunters, encountering animals that had never learned to fear bipedal predators, were able to drive species after species into collapse with startling efficiency. Animals like the mammoth or the giant ground sloth would have had no evolved wariness of human hunters. They may not have fled. They may not have recognized the threat until it was too late. The honest answer is that both things were probably happening at the same time, compounding each other in ways that made each factor more destructive than it would have been alone. A population already stressed by habitat loss is far more vulnerable to hunting pressure. A hunting pressure that might be sustainable in a healthy, well-distributed population becomes catastrophic when that population is already fragmented and declining. The two forces did not need to operate in sequence. They could have worked together, and the result was the same either way: a world emptied of its giants. What I find genuinely haunting about the short-faced bear's extinction is the particular position it occupied. Arctodus was almost certainly not a primary prey species for early human hunters in North America. It was a competitor, a dangerous one. Some researchers have suggested that as the prey base collapsed, as mammoths and horses and ground sloths thinned out, Arctodus lost the ecosystem that sustained it. An animal that size needs an enormous caloric intake. If the megafauna that supported the entire food web begins to decline, the top predators and mega-scavengers feel it first, and feel it hardest. The short-faced bear may not have been hunted to extinction so much as starved out of existence by the collapse of everything around it. That is a sobering thought, and it is one that resonates in ways that reach well beyond the Pleistocene, if you are willing to sit with it for a moment. By the way, if you find yourself going down this rabbit hole the way I do, wondering what else is still buried under the permafrost and what other stories these bones are waiting to tell, This channel is where I keep pulling at these threads. Subscribing to the thaw line means you will be here for the next time the ground gives something back. And it always does. Back to Alaska. One detail that I keep returning to is how recent all of this was, in geological terms. 10,000 years sounds ancient, and by the scale of human civilization it is. It predates the pyramids, predates writing, predates the earliest cities we know of by several thousand years. But in the context of the Earth's history, it is the day before yesterday. The permafrost that preserves these bones formed within living memory of the animals themselves. There are frozen specimens so well preserved that researchers have recovered intact proteins, ancient DNA, fragments of hair. The short-faced bear is no longer entirely out of reach as a biological subject. We are beginning to be able to sequence what it actually was, genetically, and how it relates to the bears alive today. And the picture that emerges from the genetics is interesting. Arctodus simus does not appear to be a direct ancestor of any modern North American bear species. It seems to have been its own separate branch, a lineage that evolved in parallel with the bears we know, grew to extraordinary size, dominated its continent for hundreds of thousands of years, and then ended. Full stop. No descendants, no continuation. The grizzly bears that live in Alaska today are not the short-faced bear's children. They are, in a sense, the survivors who were there when it fell. So when you see a grizzly bear in Alaska now, and they are large animals, genuinely impressive, some part of your brain is looking at a creature that was alive during the same era as Arctodus. That watched, in some ecological sense, from the margins as the giant vanished. The grizzly came over from Siberia during the same Beringian period and expanded into a landscape that had just lost its dominant bear. The timing is not a coincidence. What I am left with, every time I come back to the short-faced bear and the Boneyard Alaska keeps producing, is a particular kind of wonder that has a little grief threaded through it. This was a real animal. It walked the same river valleys that exist in Alaska today. It crossed ground that people cross now. And its skull, emerging from the melting permafrost bank of some unnamed creek, is both a trophy and an elegy. A remnant of a world so full of life that we can barely reconstruct it from imagination. The permafrost is thawing faster now than it has in a very long time, which means more bones are coming to the surface, more specimens, more data, more questions. Whatever we thought we understood about the megafauna extinction, the next decade of discoveries out of Alaska and the broader circumpolar north is likely to complicate it. That, honestly, is the most exciting place to be in any field of inquiry, the moment just before the picture clarifies, when you can feel the shape of something without quite being able to see it. I want to ask you something before we close. What do you think actually happened? Is the overkill hypothesis the real answer, or do you think the climate story carries more of the weight? Or is it something else entirely, something we have not fully accounted for yet? Tell me in the comments, because I genuinely want to know where you land on this. These are the kinds of questions I could talk about indefinitely, and the best part of making this channel is the conversation that happens afterward. If this is the kind of history that keeps you up at night, the deep past, the things we have lost and are still finding, then the next video I want to point you toward is one about Beringia itself, the drowned land bridge, and what it means for human migration into the Americas. That story connects directly to everything we talked about today, and it has a few surprises in it I did not see coming when I started digging. Thank you for spending time in the Boneyard with me. I am glad you are here. If this is your first time at the thaw line, please subscribe. There is always more ground to cover, and I would love to have you along for it. Until next time.